The grid and its letters are looking good. Let's think about the neighbours of a position. Time for another test. Here we create a test that will look for the neighbours of a position. Yet again, we call a function that does not yet exist. We call a function that we wish did exist. This helps us write code that does just enough. This test is a good example of this. A position on a grid will have 8 neighbours, unless it is on the edge or a corner, in which case it will have less. We are not concerned with those special cases yet. This function takes a position and returns the 8 neighbours it should have. We'll worry about whether those neighbours are even in the grid elsewhere. We are separating the two concerns. It usually helps to start out writing dumb functions and only make them smart later if it makes sense. Dumb code tends to be simple code, and it's much harder to make more complex code simple than it is to make simple code smart. So we can see that this has failed. There's no attribute neighbours of position. So how do we make this test pass? Well, we go and create that function. So open BogglePy and create that function. Give it the argument of coords. So this gets us the neighbours of a given position. So here we just assign each number to a variable. Now we add those variables to a list and return that list of neighbours. On a computer screen, the origin is at the top left hand side of the screen. So that is why our top row here has a -1 for row. And we have a top left, top center, top right. And of course the position will also have a left neighbour and a right neighbour. There will also be a bottom left, bottom center, bottom right neighbour. You can see here the row here is positive. So now we have a function that returns the potential neighbours of a position on the board. This test now passes. However, we now need to determine the actual neighbours for each position, allowing for both corners and edges. So we need to write a test and see what that might look like. This is a much more complicated test than we would ordinarily be happy with. It's not immediately apparent what the test does. And loops and conditions in tests are rarely a good thing. But we're going to show you this example anyway, and you can perhaps think of a way to simplify the test. The trick to this test, and tricks are never good in tests, is that in a 2x2 grid, every position touches every other position. So the neighbours of any position are the other 3 positions in the grid. In this line, we get all the neighbours for the grid. This is a dictionary where the key is the position, just like with the grid itself, but the value is a list of neighbouring positions. So this next line can assert the correct length of the neighbours dictionary. The for loop will iterate through the positions in the grid. For each position, the neighbours are the other 3 positions on the grid. So we create the others list, which is the full grid, minus the position in question. Then in the next line it asserts that the positions of the neighbours are the position being checked. It's a complicated test, but it gives us confidence that our neighbour's data structure is correct. Now we have to go back into the BogglePy code and implement a function that will make this test pass. So it's the allGridNeighbours function. We give it the argument grid, and this gets all of the possible neighbours for each position in the grid. So for each position in the grid, get the possible neighbours using the function that we wrote earlier. Then the actual neighbours are those that are actually in the grid. Save the files and run the test, and you'll see that all 6 tests now pass.